Thank you. Thank you.
And Dr. Srinivasa Kumar and there is Agarwal and audience in the room and on the desk. Good morning to everybody. And I, in the first instance, thanks Rashmi Sharma and Pradeep Tapliyal for giving opportunity to present in this workshop. Actually, SST, GHR SST, I started my career with SST retrievals and around 1990 when MOES and ISRO, so at that time Department of Oceanography and DOD and SAC ISRO together they started a real-time retrieval of sea surface temperature on operational basis, and at that time. We started, there is a plan for real-time retrieval of SST using all satellite data that is received at NRSC Hyderabad at MedDPS system, and we just started working on that one, and that led many other scientific problems identified and many institutions in that MOES are started in that one. First when we started with SST, that time DPS system one is one Mbps system, which usually take about 5 to 6 hours to process one pass of NOVA data and there. And from that time now we are almost with the inquire stage. We reached a stage within, I think within 10-15 minutes we are processing that at that fast that we take it. And first when we started retrieving the SST, we found many problems that particular to Indian Ocean. Particularly Indian Ocean humidity is more, and hence that edge problems easy to get one, and the GHR SST retrieval thing what we are using, it is that is not with humidity at Bay of Bengal. It is not, the quality of the data is not used to come that much good. So we started think of our own buoy program. The buoy program at IIT Chennai was started, and that became a big institute now, NIOT, and now it is leading that program. And that SST applications, Dr. Srinivas is representing here, that it became inquires and lot of services organizations are coming, and it also produced many Indian leaders in the oceanography and meteorology community in this one. And that type of seriously that SST retrieval thing was started that time, and after we found that that SST retrieval problem, then I moved to National Remote Sensing and CMRWF, where I started using the data and using the data of that one, and at the time in the models we are using observed SST, not observed SST, we are using the climatological SST, and then we moved to using observed SST, and we found a lot of impact of the observed SST on the model forecast. And with SAC Ahmedabad and we together, then we used forecasted SST in that one, and first time we started giving only changing the SST fields. In that one we started giving the seasonal forecasting, and that is sort of the seasonal forecasting in India. Means not there are statistical methods are there, numerical methods for seasonal forecasting. First time we started around 95 using the forecasted SST in the models. So that is the importance that SST thing is given by the Indian community using that one. Previous first it. First slide, second slide. Okay, so that is the SST provides a boundary conditions for the numerical models. And when we started simulating the direct satellite data, the SST is also required for the radiative models also to that thing. And high resolution SST was that time we started using that thing. And these are the sources what we are getting the SST. If you find the SST, as the speaker told, it is the foundation SST, but the models what required the SST of the near sea surface temperature, that NSST, and the skin temperature is more important. And if you get what are we are getting from the satellites and in situ observations, they are from the lower 5 meter level and 10 meter level, that type of temperatures are required. But what models required is a skin temperature. So the GHR SST, like earlier what speaker shown, that the GHR SST or model SST, what they are giving the foundation SST, and we have to to use the models, we have to get the skin temperature. And to get the skin temperature, some models they use parameterization of that to get the skin temperatures, and the other way is using the motion models. And at NCMRWF, we have the two global and numerical models that are running. One is the IMD GFS system, and other is the unified model and CM system, which is a grid point model system. In both the systems, we are using the different schemes for getting the near sea surface temperature. In GFS system, is the IMD GFS system, we are doing multi institutes are working on that one. IMD is working for the extend range and medium range forecast, and IITM, other our sister organizations, working for the seasonal forecasting and also extend range forecast system. And the fluxes from them, what we are getting this model, we are giving to our sister organization inquires using for the running the ocean model systems. And whereas in the system, we have the unifying modeling systems starting from the 330 meter city forecast and 1.5 kilometer regional forecast, and like that we have to 64 kilometer global forecast model for the coupled model to giving the seasonal forecast. So many scales of systems we are giving from the system. Both the systems are using. In both the systems, how we use the SST are the different. As I told earlier, the SST required in the modeling systems are the near sea surface temperatures. So what we have to get is skin temperature from the bulk temperatures what we are getting from the various observations. This is the problem for using the models. The near sea surface temperature is required because it has it not only for as a boundary conditions, but also for driving the radiative tensor models for assimilating the satellite data, other things in that one. So we are trying to get the SST from these for both the systems, and for IMD GFS system, we are computing the near sea surface temperature NSST by using the scheme by driving the derived model forecasted parameters in that one, and forecasted SST temperature also in that. And whereas as I told earlier, in and system, we are running the complete NEMO war system, and that NEMO, both the systems, I will tell how you are getting both the systems in driving that one. In NSST analysis in the GFS system, what we have to get is the near sea surface temperature. There, the diurnal corrections and also cooling due to the surface evaporation, that both the things we have to take that one. So in that we are considering fluxes, atmospheric fluxes from the model, and here we are able in the table we can see how the formula what we are using in getting the near sea surface temperature. That is, we are taking the foundation temperature and also cooling profile computed with wind parameterization, and also we are getting the diurnal warming profile and sublayer cooling thickness all are considered, and using the linear profile that we showed the top of the panel, we are computing the linear temperature at the near surface. And whereas in the other model, we are completing the NIMOVAR system. This is the NIMOVAR details are given here, and various at present we are going NIMOVAR 3.6 model in that model, and we are that is having the 1442 by 1021 grids, and we are using ORCA 0.25, that one. In that, the flow chart, how we do observations, what are the observations? We have the observation pre-processing system, all observations, in situ observations, what we are getting from the GTS data we are getting, and also we are getting the observations from the satellite observation from the NOVA and UMETCAST directly through the reception system, and our NIMO model we are running that will cover the first guess for that one, and every day we are running the one cycle per day and getting all the observations, pre-processed and quality checked observations, and running the system. This diagram shows complete flow chart, how that assimilation system being run in the NIMOVAR system. And we have the complex observation quality control for that one. And this is the complete details of NIMOVAR system, and the table at the left-hand side shows that how that from the atmospheric model we are getting the zonal meridional winds and the shortwave radiations and specific humidity from that one, and surface temperature from the model we are considering that one, and rainfall, and these things from the atmospheric model we are using, and the NIMO sea ice analysis from that one we are taking, and 75 level ocean levels are there in that one, and for every 20 minutes step we are doing that one, and 3D var FGAT. FGAT means we are getting the first guess interpolated to the observation time. We are interpolating the first guess to the observational time and running the system, and we are taking the bathymetry and the river runoff all into considering to the model into that. And it is a variation analysis system, so the temperature, not only the temperature feature, all other observations also influence on each other. Suppose salinity observations also get affected by the temperature observation. So the balance of the temperature, TS balance has shown taken into consideration that one, and hydrostatic balance, and you can see all the things are taken into that one. And we are doing the variation analysis and observation operator, converting observation to the other observations also to the model variables. We have observation operators, and it is shown as this D is equal to that H is an observation operator, and it will interpolate background error, background operator to that one, and also consider background error and observation error and all into considering to that considering that one with this variation, this minimization work on that one, will get the minimize that one, get the analysis for that one. And if you see that one, that observational covariance of the model and the background error covariance from the systematically we are computing from the it is generated from the model, and they are also considered in the weighting the functions that one. So we are for that one we are taking all observations, Argo observation TS profiles up to 2000 meters, and the moved buoys we also taken that one, and drifters, XBT, and various spatial patterns that observation are shown here, and all these things are taken to that one. And we are also considering the satellite observations, altimeter, GHRSST, and SSIMS, CIS concentrations. All these things are assimilated in the NIMOVAR system, and these things are used in observation processing system for that one, and this is the total observation processing system what we'll do with that one. And observations are interpolated or processed using an OPS system that what we have, and using that we have the quality controls is required. And what is the quality controls? And these quality controls we are taking is tabulated here. Range value are taking that one, getting the higher values, and we are doing the duplicate checks because we are getting many observations from the all sources. So duplicate checks we are taking to that one to consider remove that one, and also we are taking quality with control with the background error, which is too much different from the background error. We are removing that one, and for the satellite observations. To get the uncorrelated observations, which is not able to, it is not required to use all the observations, because observations are most of satellite observations are correlated with each other. To get the uncorrelated observations, we are doing a superobing for thinning the satellite observations, such as very high resolution observations, because they are correlated. We have to do the thin superobing for removing the correlated observations, and for that removal we are doing the thinning the observations on that one. And some of the XBT observations or the other things, because using the quality checks also provided in that one, and to remove the stability using the stability quality checks to remove the observations. For SST, see, using the GHRSST, we are telling why the bias corrections are required. Is required doing that one. See, it is we are this second GHRSST we are compared with the buoy locations all over the globe, and you can see that this GHRSST with buoy, we have the bias, standard bias about 0.77. They are very well represented, very well correlated, but they have the bias, very high bias, and RMSE difference also very high. So before using this observation, it is required to the bias corrections. Like that, other observations also, the bias corrections and quality checks are required to get the proper observation things. And here to show the importance of the SST observations utilization, and we did an observation system experiment using the GHRSST as without GHRSST, how the GHRSST is influencing the analysis, SST analysis. In this one, we comparing the number of observations what we are receiving global wise, and also to show Indian Ocean, how much Indian region, how much observations we are getting about the SST. We're comparing the winter and summer lot. 1 year, some statistics were showing that one. We can see we are getting many observations or Indian region also. There are special efforts from the MOES for getting the Indian region observations, and that observation level, number of observations what we are getting is more. And GHR satellite observation, here what we are showing is the satellite observations because of the cloud SST observations affected with the cloud things, or seasonally some regions cloud we are getting the as shown in the SST observation, the data gaps we are getting that one. These data gaps also will be filled with the analysis systems. So for correcting the bias corrections and this one, there are many techniques are many people are feeling that one. One is the OASST they are generating for the bias correction, and here we are doing the variation analysis system itself. We are making the corrections for the bias corrections for the observations by taking into the first guess and model history into consideration. We are doing the bias correction in the next one. And to show how observations interlinked, affecting one observation is a variation analysis. Not only SST observation will not only affect FSST observation, because that analysis things will get the even SST analysis, SST observations also will impact C surface salinity observations increment. Those things, those things we can see here. The first slide shows that control where we are using only the without using the GHR SST, how it is impact, how it is bias, it is showing. And whereas the second slide in the left side, that experiment with SST, it shows that the impact of the HRSS, it spread. Only buoy data you are telling, if you are simulating, you are not getting the impact, that very limited regions. When you are using the experimental SST with GHSST, you can see the lot of improvement of the things as shown in the B slide. And this SST implements not only affecting that one, it is even the salinity observations also getting affected with the utilization by affecting the SST observations also, improvement the salinity observations also, because that what I showed, that that link is there, and we can see we assessed the impact of the SST observation thing on with Rama boys observations, and it is clearly shown that bias and improvement with Rama boys, that SST the GHA SST simulation, or the without using the GHR SST, we are getting the impact much more. Bias is impact bias, and even buoy region also the impact is there, and assessed. And similarly, we computed that this northern that what is this impact of the fluxes also, where that is affected in the SSH and surface current fluxes. All parameters are getting affected with the assimilation of SST in that one. And not only C surface GHR SST, in this slide we are showing that not only the surface temperature assimilation not only affecting the surface level, even deeper level also the impact is getting affected. You can see up to 60-meter level the sea surface temperature data assimilation is giving the temperature profile up to the deeper level, up to 60-meter depth also, it is impacting that one.
Dr. Prasad, can you please conclude?
Yeah,
thank you.
And SST, it is also wind observation. If you compare the wind stress is also getting getting impacted with SST observations. Finally, this will show that ocean analysis, total analysis with the NIMOVAR system, what you are getting that one. And the above, this slide shows the impact of the SST on wind stress, other things is shown, use of ocean coupled data simulation. This impact is felt, requirement is felt, and then now we are trying to use using this NIMO SST and other variables in the ocean assimilation or ocean NWP fields also. We are now with OASIS coupler, we are using coupling the land data, ocean data, and in the NCM model where coupled models are in place. And in the near future, we are going to implement NWP based, coupled based NWP system. At present, we are giving only atmospheric forecast only. Atmospheric model only we are running for the NWP, and for seasonal forecasting we are doing the coupled model. And with NIMO implementation and showing the impact that we are getting in the short scales of the ocean fluxes and other things, we are going to implement coupled NWP and coupled DA for near future. And I think by this year end, we are going to implement coupled data simulation using the SST, GHR SST, and all these things for the numeric and new short range forecasting and other fields also we are going to implement that one. And this is to show the impact of the software system.
Thank you very much, Dr. Prasad.